So we are going live right now.
Okay.
Good afternoon to all respected faculty members, dear students, and our esteemed viewers. On behalf of Department of Basic Science and Humanities of University of Engineering Management, Kolkata, I would like to extend a warm welcome to all of you in today's distinguished lecture series on analytics, Foresee the Future with Numbers. We are thankful to our Honorable Dean Science of UEM Kolkata, Professor Dr. Rajiv Ganguly sir, and our Honorable HOD, Professor Dr. Kartik Shah sir, for their extended support. It gives me immense pleasure to introduce Mr. Arijit Pal as our speaker of today's online seminar. Mr. Pal, who is currently working as Assistant Manager, Decision Science in HSBC, has vast industrial experience in data analysis. Mr. Pal has completed his graduation from prestigious Presidency University and post-graduation from internationally renowned Indian Statistical Institute. Prior to his joining in HSBC, he has also worked as senior biostatistician, clinical development and analytics at Novartis. So, without further delay, I would like to request our speaker to take charge of this distinguished lecture. Over to you, Mr. Pal, and thank you.
Yes, yes. Thanks. Thank you. Uh, uh, Hello, everyone. Welcome to this distinguished lecture series session, and thank you, UEM, and thanks to all the professors who are coordinating it. I hope everyone who are listening, everyone are safe in this situation. So, without further delay, we can start. So, as you all know, the today's title of our lecture series is analytics. So what I will do, I will basically discuss the fundamentals of analytics and how it is applied on the industry. Uh, I would not be discussing technical details and the mathematics and the statistics behind the analytics. Rather, what I would do, I would cover the application part of it. Because the mathematics you can learn always in your university, but the things that you not know in your university, how is it applied in your in the industry that you would be working on. So let's get started. So what is actually analytics? So analytics actually a multidisciplinary domain. So by multidisciplinary, what I mean is that it actually comprises of several subjects like statistics, mathematics, of course, computer science, and economics as well. So so if you are going to be an analytics professional, you need to know some things about all these subjects. But so where does it start? It starts with a business problem. Then, based on my statistics, mathematics, and computer science expertise, I would reach to a business solution. So that's how the flow of an analytics professional works. So it starts with a business problem, it concludes with a business solution. And notice the word business here, because the problem has to be a business problem as well as the solution has to be a business solution also. What do I mean by business solution? So business, so not every solution can be implemented or can be realistic. For example, let's say I have provided a solution to a difficult problem which takes 10 years. So that will not be feasible for a business to implement, right? So the solution has to be a business in terms of realistic cost and time efficiency, and of course the problem is definitely have to be business. We are only dealing with business problems here, not theoretical fundamental problems. So every company has some business issues. We will be discussing in details what kind of business problems we face. But from the beginning to the end, we are dealing with business and business only. So why do we use analytics? Uh, Analytics actually a combination of algorithms, scientific methods, and models. Why do we use it? We use analytics to know the background story of the data. So what's the story that the data wants us to tell, wants to tell us? So what is the background story? So it's a discipline which helps you to process and summarize voluminous heterogeneous data to gain insights from that data. So what is the decision that you would reach from that data? It captures nonlinear complex relationships between variables. So in real life scenario, we encounter many variables, right? So it may be GDP versus our unemployment rate. It may be GDP versus our national income. It may be GDP per capita versus our economic scenarios. Things like that. So relationship between these kind of economic variables or realistic business variables do not always have linear relationship like we see in physics. For example, speed equal to distance by time. So with a constant speed, distance is having a linear relationship. So not always we would face a problem with this kind of simple linear relationship. So analytics helps us to capture that non-linear complex relationships between the variables of our interest. So let's say, just for a quick example, let's say how unemployment rate affects our gross domestic product per capita. So you can always intuitively guess that if our unemployment rate rises, the GDP decreases, right? But the question to answer is, does it decrease proportionally? So it may not decrease proportionally also. So in these kind of relationships will be captured, or we try to capture as analytics experts or analytics professionals, we try to capture these kind of relationships. Uh, and why do we, one of the major reasons also for doing analytics or implementing analytics tools in a company's business is automation. So why is company investing so much money? So nowadays you all know what the companies are investing money in analytics, machine learning, artificial intelligence. And this, you must have heard all of these terms in recent years. So what is it actually? So why do companies invest in this? So one of the major reasons is automation. So automation is a major part of this analytics world, where you do not have to employ manual labor to do some task. For example, let's say you want to see who is violating the traffic. Okay, so for us in Kolkata, what do we see? We see that the traffic sergeants are there, right? So imagine a scenario where in the traffic crossroad, you have actually put a camera, and the camera is able to detect your license plate when you are violating the traffic. So if some system like this can be implemented in the traffic crossroad, do you think the job of that traffic sergeant will be much less? So the burden of the traffic sergeant. So let's think about from the burden of the traffic sergeant's perspective. So traffic sergeant doesn't need to go after every vehicle who is violating the traffic, right? So the CCTV camera can capture the license plate of the vehicle, and it can automatically send the penalty amount to the owner of that vehicle. Basically, it reduces the human intervention, and that way it reduces human error also, and of course minimizing the cost and time, definitely. So that is the reason we use analytics. When do we use it? So we companies use analytics when they see a big opportunity to minimize cost actually. So they use it to minimize cost. So what are the several examples where they want to use analytics? So I have given, so you can see on the slide, left hand side of the slide, that where data science or analytics are used. So I'll be quickly going through a couple of examples here, of course, and I'll be detailing on some of the sectors in my later slides. But let's say fraud and risk detection. What does it mean by fraud and risk detection? So it is a big deal in financial industry, because the industry of finance is full of fraudulent fraudulent crimes and the risk of losing money. So financial industries need to be capable of mitigating that risk. So that is why they dedicate a separate department itself for fraud and risk detection. It is called Financial Crime Risk Department. So they dedicate a separate entire department for that. Then it comes healthcare analytics. Of course, pharmaceutical companies are using analytics. I'll be diving into deeper examples regarding this healthcare analytics also. What is targeted advertising? Targeted advertising is what you see on the Netflix. So whenever you watch a movie, you can see the similar kind of movies are getting recommended to you. Whenever you buy something on Flipkart, you can see the similar kind of items are getting recommended to you for buying this. Or let's say you are buying a phone, then you would see the back cover of the phone is getting recommended to you. Say buy this, buy that. So that is basically targeted advertising. So do you know who does all this? So there is not any single person sitting behind the computer and who is targeting you that okay, Mr. X, you have bought this phone and this is your back cover you might be needing. No, that's not how it happens. Basically, machine is doing all these things. So machine is actually capturing your buying pattern, what kind of phone you have bought, what company or what is the company of that phone. So is it a Samsung phone or it is an Apple iPhone? So what's that company? Do you need is it coming with an AirPod or is it coming with an headphone? So let's say the Samsung does not include headphones in your box. So what you will see, the Flipkart is recommending an headphone. So who does all this? So machine is automatically detecting those facts. It is capturing that pattern that it does not have that headphone. So let's give that customer an option to buy that headphone. Okay, so that is basically targeted advertising. So website recommendation. Next is website recommendation. So what is website recommendation? Website recommendation is basically what you see when you search Google page. So you search some strings in your Google search tab, and you would see millions of websites with page 1, page 2 occurs, right? Now, how then those pages are ranked? So what are the websites that you would see on page 1 and what are the websites you would see on page 2? That is basically determined by a machine learning algorithm. Okay, it is called it's actually Google's famous index searching algorithm. So it basically what does it do? It basically matches all the keywords that you searched in your type boxes and goes through millions of websites and finds a match. What would be the suitable website based on your searched text? So let's say you searched IPL. So what do you think the first website would be on the page 1? Of course, the IPL official website would be there. But apart from the IPL's official website, there will be many other websites covering the IPL stories also, right? But that will those IPL websites will be coming later. But the first one will be the IPL's official website. So things like that. This is called website recommendation. Advanced image recognition is basically just the example that I just gave regarding the traffic police and the capturing the violating vehicle detection. So that is a basic example of advanced image recognition. Or nowadays, actually, in this pandemic situation, people are developing advanced image recognition based on whether you are wearing a mask or not in public. So if you are not wearing a mask, so the camera will capture your face, and based on the face that is getting captured, your, let's say, the social security number, or in India the Aadhaar number will be mapped, and you will be sent let's say punishable, or you will be sent a penalty, let's say, if government imposes a penalty for not wearing a mask. So that is how it will be done, and in some countries actually it is done. But the technologies are still in the development phase, so not sure when India will be using it, but yes. Airline route planning. So airline route planning is actually a complex example of analytics. So in an airport, so you can imagine, so there are many destinations. So planes are coming to the airport and planes are going from the airport, right? Now, if you see, or if you think about it, the airport actually has at most 3 or 4 maximum runways, right? Now, based on the departure time and the arrival time of those airlines. So what is the optimum way so that no flights has to delay on that sky. So sometimes it happens, I don't know, maybe some of you must have faced it. So when you are in a flight, sometimes when you are near the destination airport, the plane actually circles around that sky, that the sky near the destination airport. So one of the major reasons for that is definitely weather, but another reason could be that there is no slot for landing immediately. So what does it do? It circles couple of times and then it landed. So then it lands. So that is a kind of example where airline route planning is involved. So you have to manage that optimally. So the possibly none of the flights have to face that delay. Of course, then we come to banking and the retail sector. Banking definitely uses analytics. I'll be coming to that, how banking sector uses analytics. And the retail sector, what do we mean by retail sector? Retail sector essentially means so you are the retail customer, right? If you buy something from Amazon, you are the retail customer. So retail sector is basically where individual small customers are involved. So they are not high net worth individuals, or they are not buying a large real estate apartment or a large villa, but rather they are individual small customers. So those are called retail based. So think about every scenario where you buy something as a retail customer, you will find some application of analytics. Now, so if you look at the right hand side of that slide, so I have terms, couple of technical terms. So what is those technical terms? What are those technical terms? Is like classification problem. So classification problem, regression problem, and then it comes design of experiment, then it comes time series. So what are all these? So let me give you a quick example of classification problem. So classification problem comprises of classify a certain variable between, let's say, two distinct states. So for example, do you know how credit cards work? So when you are applying for a credit card, you have to fill up what's your monthly income, you have to fill up your area of residence, you have to fill up your state and the location, all these things, right? Now the one of the important parts when you apply for a credit card is the monthly income. Now, do you think any particular person is sitting behind the banking server and checking your website application? No, it doesn't work like that. So there are thousands of applications for a particular credit card. So how many employees bank will hire if bank needs to do it manually? So they don't do that. So what happens behind the scene is that a machine learning algorithm is in place. So what does it do? It basically takes all those information you have just put regarding the residence, regarding the annual income, regarding your age, regarding how much or how many years of employment experience you have. Based on all these things, so the machine learning algorithm will be saying whether you are eligible for a credit card or you are not eligible for a credit card. Okay, so basically there can be two options, right? When you are applying for a credit card, either you are eligible or you are not eligible. But so these two distinct options are called a classification problem. So the machine learning algorithm is able to detect whether the bank should give you the credit card or not. Now next comes a regression problem. So what is a regression problem? Let's say you are eligible for the credit card and the machine learning algorithm has detected that, okay, you have a very good salary, you have a 5 years of experience in employment, you are residing in Calcutta, so you have a very good background. So the algorithm will naturally detect that, okay, this person might be given a credit card. Now comes the next question. What should be your credit limit? So you all know, right? In a credit card, you all have a credit limit. So for example, you might have credit limit of 50,000 rupees. So you cannot, in a monthly cycle, you cannot spend more than 50,000. But how banks decide that credit? How do they decide that? So that is basically a regression problem, because if you think about it, the credit limit number is a continuous variable, right? unlike the previous problem where the machine learning algorithm has to detect whether or not you should be given a credit card or not. So it's basically a binary situation, yes or no. You would be given a credit card, yes, or you would not be given a credit card, no. But after we solve that problem, there comes a regression problem of deciding the credit limit. So what should be the optimal credit limit, so that, so why deciding optimal credit limit is important, because let's say you have a salary of 100 rupees and banks give you a credit limit of 1,000 rupees, so that will not work, because you will spend around 500 rupees and you will be going into a default, because your salary will not be covering that much of a credit limit. So what would be that optimal credit limit based on your salary and your spend behavior? So how much? So let's say some of us are actually spending. This is the time of puja. Some of us are actually spending 80% of their salary. So if you spend 80% of their salary, bank will naturally agree to give you a higher credit limit, because bank knows that they will be having a better profit from you, compared to another one who is spending only 20% of their salary in this puja time. Okay, so that is the customer pattern, or that is the spending behavior actually banks look into. Now you might be thinking, where do the bank get those kind of data? How much I'm spending on what items? So if you think about it, whenever you are buying something in Flipkart, or whenever you are buying something in Amazon, or whenever you are searching your products on Google, all those informations are actually going somewhere. So you use Google for free, but that does not mean that you are not giving something to the Google. So what you are giving something to the Google, you are giving your pattern or your behavioral information to that Google. So Google uses that information. So Google will not personally identify you. That is for sure, because that's the portion where the security comes in. So it will not personally identify you. Rather, it will identify like this. Say, in time of Durga Puja, people of Calcutta spend 50% more than compared to what they have spent on the entire year. So that pattern is very important for a global marketing company like Amazon, or say Indian marketing company or Indian e-commerce company like Flipkart. So that is the reason that is the reason they actually capture that customer behavior. But all this information getting processed, all those information are processed to this machine learning or analytics algorithm. Okay, so another kind of example would be design of experiment. So sometimes what happens, to answer some business problems, you need to actually devise a design of experiment. So what does it mean by a design of experiment? So let's say I'll be coming in details with this context. What does it mean by the design of experiment? So just let me give you a quick example on that. So let's say you are trying to know whether your startup company will be able to actually be a big company in future. So how does startup system work? So startup systems work like this. So startups generally start with a product. So let's say the Swiggy. So how did it begin? So what they did, they actually started in a small city, in a city like Bangalore, and they chose a certain area at the very beginning of their startup. So after that, what did they do? They launched their app to certain people of those area only, not all over the India. So only to a certain area of Bangalore city. So based on the customer behavior and based on the customer purchasing pattern, on those small controlled experiment, they decided whether it is worth, or they decided whether it is worth to invest money in this kind of product, in this kind of food delivery product. So that's how startups work. They, before going to any investor, they actually do a small scale controlled experiment on their product. So let's say I am a high net worth individual and I have money to invest in a startup. Now anyone can come up with an idea, right? Anyone can come up with an idea and ask me that you have money, so give me some money in my startup. So how? But why do I do that? I would invest my, so I would not want to lose money, right? So I would invest my money to a startup only if the startup is viable. So how the startup founders prove that my startup product is viable? So they start with that basic small controlled experiment. So that is where the design of experiment comes in. So what does they do? They carefully choose the location of experiment. They carefully choose which person should be included in those experiments, and then they assess their question whether my product will be viable for publishing to a larger population or not. So that is how startups work, and that is the importance of design of experiments there. And of course, we have techniques of time series and so on. Time series is basically a time series analysis. Of you have so let's say you want to see the periodic component in my expenditure. So you can also individually do that. So in time of sales, you will be spending much more. So that analysis you can very nicely do in a time series analysis. So these are basic examples of analytics. When do companies actually use analytics? So I'll be going to the next slide quickly. How to use it, definitely. So as I said, it starts with a business problem. So we, as analytics and data science professionals, we have to understand what is the question that we are trying to answer. So not every question actually needs a big analytics algorithm or very fashionable analytics. Not everything needs that. So sometimes a summary table, an average actually basically more helpful than complicated algorithms. So, but sometimes no. There are many complex problems which cannot be handled by a simple methodology. So the basic step is basically understanding the question we are trying to answer and the business context around it. Definitely the business context around it. So we have to understand the business context before providing any solution, because if at the end of the day, at the end of providing solution, business will be using it to reduce their cost and time. So the time and the cost effectiveness should be maintained throughout all the process of analytics, using analytics or using data science or using machine learning or any artificial intelligence, anything. So whatever you do, you have to keep that in mind that the business will be using it and they want to minimize their cost. They do not want to spend more money to do some fancy analysis if that doesn't help them. And at the end of your analysis and all these things, so you have to provide that solution to the business so that they can actually implement it in their system and they can get benefit out of it. So that is how the flowchart of the flowchart of the responsibility of analytics analyst on data scientist. So we have to use appropriate techniques. We have to accumulate relevant data, of course. So let's say we want to see whether these customers should be given a bank loan on their mortgage. Now the customer is the father and I am accumulating data on the son, so that would not be a relevant data accumulation. So it should be around the question, around the business question that we are trying to solve. So the relevant accumulation of the data is very important first. And then of course the appropriate techniques, and then robust and reliable solution. Of course, it needs to be reliable, because after 1 year of using that solution, if it fails, then the money spent is basically worthless. So it has to be a robust and reliable solution, because if the business will be using for many years, many coming years. Yeah. Okay. So as in the beginning, I said that instead of going into mathematical or statistical details of analytics, I would be actually discussing some stories, and so this will be a storytelling session basically, and I have picked up these stories from my own experience. So I have worked in pharmaceutical industry. Now currently I'm working in financial industry. So I'll be sharing what exactly kind of problems, or what exactly kind of basic problems at least we deal with in analytics. So let's consider pharmaceutical industry first. Before going into, if you notice the question is how many patients to recruit. So what does it mean? I'll be coming to that. But before getting deeper in this slide, let me give you a quick thought experiment. So let's say you are given a coin, simple coin, and you are asked to tell me uh, whether the coin is a fair coin or a biased coin. So you have to tell me, you are given that coin, you have to tell me whether the coin is unbiased or not. So what would be the most natural thing to do to see whether a coin is unbiased or not? Having the coin with you, what would be the most natural thing to do? The most natural thing to do would be to toss the coin a couple of times, simply. So let's say you toss the coin 10 times and 9 out of 10 times the head comes up. So, in that case, you would be little skeptical to say that the coin is actually unbiased. So you'd be more confident around saying the coin is actually biased and it is biased towards head, right? Okay. Now, here comes a question. The question is, so I just said you might toss 10 times. The question will be, so how do you decide how many times you will be tossing? So you could have tossed 20 times also, right? You could have tossed 100 times also, or you could have tossed 1,000 times also. In that, if someone asks you this question, that how many tosses you will be doing, how many coin tosses you will be performing, the simplest answer will be as many as I am allowed to do. So basically, the more tosses I will perform, the more coin tossing experiment I will perform, I will be having, or I will be gaining more confidence around my decision, right? So let's say I toss 10 times and 9 out of 10 times it comes head, and my friend tosses the same coin 100 times and it is coming out, let's say 90 times out of 100. So my friend will be more confident saying that this coin is definitely biased because out of 100 times, 90 times it is coming head, right? So how do I decide on that number, 10 or 100 or 1,000? You have to decide that number based on the cost. Now, this is a simple example where you are tossing a coin, and tossing a coin doesn't actually require any cost associated with it. But just imagine, for the sake of this experiment, every time you toss that coin, you actually incur a cost of, let's say, 10 rupees. So then you would not want to, and you have a limited amount of money, right? So your friend might have a better, much higher amount of money. You might have a little amount of money. So in that case, you would not be wanting to, toss 100 times. Based on whatever amount available to you, you would be doing that tossing experiment up to that amount. But uh, while you are deciding the number of tosses that you will be doing, you have to make sure that your number is sufficient enough to have or to give you some confidence around it. Okay. So if you have 100 rupees, you can say, okay, I'll do tossing 10 times, but doing 10 times tossing, does it give you sufficient confidence to say that whether your coin is biased or not? So that is the question where statistical hypothesis testing comes in. That is the question where that is the problem a basic pharmaceutical industry faces. Now I'll be relating this coin tossing experiment to a real life scenario of how it is used in a pharmaceutical industry. So before going into that, let's just give you a little bit background on how medicine companies work. So whatever medicines or whatever drugs you see right now in a market, those drugs are actually uh, published after going through a rigorous process of testing and then analysis and all those things. So because what's the reason for it? Because the drug industry is basically a very heavily regulated industry. You cannot just come up with a drug in your go down and sell it to a market. So that you cannot do. So there is a regulatory authority in India also. In America, it is called Food and Drug Authority. In Europe, it is called European Medicine Agency. In India, it is called CDSCO actually, Clinical Drugs Regulatory Standard, something like it. I forgot the actual name, but there is a regulatory body in India also. So what does it do? This regulatory body actually oversees the methodology by which you are preparing your drug and the evidences whether your drug is actually working and it is actually safe and working drug to be published in the market for a general population. So before publishing a particular drug, it has to go through a rigorous process of testing. So this rigorous process is actually called a clinical trial. So if you notice the keywords I have mentioned here, so it is called a clinical trial. So in this time of pandemic where everyone is trying to come up with some vaccine, you must have heard this term clinical trial, and you must have heard some reliable doctors that vaccine actually takes more time. Vaccine actually takes a sufficient amount of time to come up with, right? So what's the reason behind that? The reason behind that is that you cannot just create a vaccine and use it to a general population. You cannot do that. You have to do the rigorous testing. When a clinical trial happens, it starts with a preclinical experiment. So what does it mean by preclinical experiment? Preclinical experiment is happens on animals. So what is the drug actually? A drug is actually the organic compound. Whatever you have read in your class 12 chemistry, those kind of component is basically a drug. So a drug is nothing but a organic compound. So basically carbon compound, sometimes an alcohol compound also. Now, whenever a drug is synthesized in the lab by let's say biochemist or bioscientist, so it first starts with a preclinical experiment. So preclinical experiments happen on animals, so guinea pigs or rabbits or rats. So they test the toxicity of the drug there. After proving that the toxicity of the drug, there is nothing much to prove, and the drug is not toxic, they goes to phase 1 clinical trial. And phase 1 clinical trial is where the drug is first tested on humans. Now, phase 1 clinical trial happens on healthy volunteers. So healthy volunteers like you and me. So you do not have any disease to start with. So you are a healthy person. But it starts with a healthy volunteer, with a bunch of healthy volunteers. Now think about it. Let's say you are so there is a drug company. The drug company is asking you to be their healthy volunteer. Will you go for it? That is an unknown drug will be applied to you. Will you go for it? In a normal scenario, you would not go for it, right? So if the drug company is saying that I just apply a unknown drug to you, will not go for it. So they offer money. So that is how clinical trials actually work. They offer insurance on your body and they offer you money. Now say they will be saying that monthly I'll be giving you 15,000 rupees, but you have to prove that you are a healthy volunteer and come to us for our. Then you might be tempted to go to this drug trial, right? But think about company's perspective. Company has to spend 50,000 or 15,000, whatever the amount per month to you. So company is also incurring a cost in this clinical trial. Now company is recruiting you for certain purposes, right? In the phase 1 clinical trial, what is the purpose? The purpose is to prove that the drug is actually safe on human body. So that is why they are recruiting healthy volunteers, because if you recruit a sick volunteer or who is already having some disease, so you would not be knowing whether the drug is actually having some side effects and toxicity because of the drug or because of that person itself, because the person is already sick. So in the phase 1 of the clinical trial, where the safety and the toxicity of the drug is experimented, the healthy volunteers are needed. Now, healthy volunteers actually need to be given certain amount of money, and the certain amount of insurance costs are there to ensure their health and all the hospitalization cost and all. So the company is also incurring a cost. You are also you are also getting some money, but having with the cost of having your body in that experiment. It's kind of a coalition game. So where everyone should win at the end of that trial. So at least we push for it that the healthy volunteer will not be getting sick, and I will be getting, and the company will get their result. Now think about it and relate to that previous coin tossing experiment. How many healthy volunteers can the company should hire, or how many patients that company should recruit? The company is incurring a huge amount of cost for giving the money to that patient and insurance, right? So it cannot, hire an unlimited number of people to their drug trial. So there has to be an optimal number. There has to be a sufficient number to be recruited to their drug trial so that their cost is minimized. Along with the minimization of the cost, they need to be confident about the fact that after the trial, the result that they will get, they are confident about the result. Okay, so let's say you have to prove whether a drug is safe or not. So do you know So basically, they come up the number 10 is analytics. So that is where the analytics comes in. And these analytics is called sample size calculation. This is the next bullet point here. So how sample size for a particular trial is calculated, that requires some technical discussion on statistical hypothesis testing and power of a test. But the purpose of doing all these things is to come up with an optimal number to recruit. The optimal number will help the company to minimize their cost, as well as to be confident enough to establish the fact that whether the drug is safe or not. It may not be the case that after every trial of every drug, the company will find that the drug is safe. It may not be. The drug might be toxic in real life also. So they have to recruit enough people to show that also, that the drug is actually toxic. Because if they fail to do that, if they fail to prove that the drug is toxic in the phase 1 trial, when they go to phase 2, the toxicity of the drug and that when the drug will be applied to the sick people or the people with having the disease, the toxicity will be severe because they already have that disease. So think about the loss from that. Think about how much loss that the company will incur to something like the drug is toxic. So that's a huge challenge to come up with that optimal number and come up with an optical scenario to design that experiment. So the design of experiment also comes in here, to where the ultimate purpose or ultimate answer to give is this number sufficient to prove that whether the drug is actually toxic or the drug is actually safe. If I can do that, and that number actually comes with a mathematical model. So if I can do that, I'll be confident, at least theoretically, I'll be confident enough. And that's the base that we can do to be theoretically confident, to be mathematically confident, rather, I would say. So in the left hand side picture, what you see is basically a quick example of a controlled experiment. So what they do, they basically recruit a bunch of people and they randomly assign the drug and the placebo to that. Placebo is basically a sugar pill. So to overcome the bias, actually, you would not know as an healthy volunteer to the clinical trial experiment, you would not know whether you are given the actual drug or the sugar pill, okay, right? So you would not know that. So because if you had known it, so it would be leading to some biases. So you would not know that. So what they do, they randomly divide the bunch of people they have recruited to two groups. One group is called treatment group, where they actually apply the drug in question, and another group is called control group, where they actually apply the sugar pills, or they apply, this is called placebo. So the placebo and the actual drug look exactly same, and as an healthy volunteer who are recruited by the company, you would not know whether you have been given a placebo or the drug. So this is required for random. So this is called the randomization of the patients. This is required to avoid conscious bias. Okay. So this is a basic example of how clinical industry works, and this is the first step where the clinical industry faces this problem. Okay, I'll go to the next story. Okay, so this is a story. This is the story which also comes from pharmaceutical industry itself. So some drugs actually have the tendency of having your heart rates increased. Okay, now when you are manufacturing a drug, let's say manufacturing a drug for a viral fever. So if you are manufacturing a drug for viral fever, you would not want to have a heart attack, right? That you would not want. So I was involved when I was in Novartis. I was involved in this kind of project. So where you have to prove that okay, my drug is working on my viral fever, but along with the fact that it is not actually causing my heart attack. So that you have to prove. Otherwise, the regulatory bodies or the FDA or the EMA or the Indian regulatory bodies will not allow your drug to publish your drug in your market for general population. So your drug might be working on your viral fever. It might be reducing your viral fever quickly within an hour. But let's say after that hour you are having a heart attack and you need to get hospitalized in hospital. That you would not want, right? So that is the reason. So this is one particular kind of problem pharmaceutical industry faces, and this analysis is called concentration QT analysis. So in the bottom left hand side you can see an ECG graph. And this interval is called a QT interval. So if it increases, you will be having a chance of heart attack. So it's simply like this. So it should not be increased much. Now, based on analytics, you have to prove to the regulatory bodies that okay, my drug is working, but it is not actually increasing that QT interval, because QT interval is actually QT interval will cause the heart attack. So the QT interval should not be increased. That you have to prove based on the data you have gathered from the patients that you have recruited, and based on the analytics that you have done, you have to prove that to your regulatory bodies. See, look, this is the drug, this is working, and this is not actually causing any heart attack. This is another kind of example in pharmaceutical industry. I'll quickly go to my next story. So this is the last story that I have here, and I think I am little behind time, but I'll finish this story also. So I have talked a lot of things about pharmaceutical industry. Now for a different flavor, let's talk about the banking industry where I currently work. So do you know how banks actually work? So what is the asset and liability of a bank? So assets for a bank are the loans they give or they hand out to people, and the liability are the deposits. So you, me, and everyone has a bank account, right? And we deposit our money. So by depositing our money, I am having some faith on banks that they will return my money with some insurance, right? Sorry, some interest. So that is the liability from the bank's perspective. Bank needs to give back the money. So that is why the deposited amount is bank's liability. What is the asset for a bank? The asset for a bank is the loan they give out, or the loan they lend. So let's say you have a mortgage and you have a home loan. So the bank actually bought the home for you, and you are paying interest, you are paying principal, something like that. So that is by that way, bank is actually receiving money. And we all know if we receive money from some source, that is the asset, and if we need to spend money somewhere, that is the liability. So from bank's perspective, the asset is the basically the loans, and the liability is the deposit. Now, let's say bank is how from where bank actually lend out the money. Bank actually lend out your money. What money public deposited to the bank actually lend out that money, because bank doesn't have their own money, right? So bank doesn't print money. So bank actually, so if some banks have to give or have to loan some amount of money to some customer, they have to have that money from somewhere. So what does that money come from? The money comes from the deposits. Now let's say whoever the bank lent out that money defaults. Defaults means they cannot pay back. Now you come to bank, and as a depositor you come to bank and say, return me my deposit. The bank will fail to give you or bank will fail to return you the deposit, because bank has already lent your money to some lenders, right? So that is the reason regulatory bodies wants to ensure that whenever, as a depositor, whenever you go to the bank, bank needs to able to give you or return you your deposited money. That's the basic right that you have as a depositor. And if bank fails to do that, then the economy will be, so there will be chaos. If bank fails to do that, so to ensure bank does not fail to do that, or bank does not become insolvent, this event is called insolvent. Bank being not able to pay your deposited money, this event is called insolvency of a bank. So how to protect banks from being insolvent, what governments do, governments or regulatory bodies, in India it is Reserve Bank of India, what they do, they oversees us, they oversees the banks. They want bank to have enough capital in their in their enough capital in their pocket, so that even after all the customers, or even after customers default, they would be able to return the deposited money. So at least they have to do that, because that's the basic right as a depositor you have. So governments wants to ensure that particular fact, that banks must be able to deposit, or banks must be able to return back your deposited money. But let's say I am a bank and I have lent out all the deposited money to some customers, like let's say Nirav Modi or Vijay Mallya, and they have defaulted, and they have not returned the lent amount. Now as a depositor you come to me and ask me for your money, I will not be able to pay that. So Reserve Bank of India actually wants to ensure that that doesn't happen. So that is basically the to prevent the insolvency of a bank. Now to prevent this insolvency of a bank, the regulatory bodies require banks to have a minimum capital. So that is called minimum capital requirement. Now I, as an analytics professional, come into the calculation of this minimum capital requirement. So what is the minimum amount of capital my bank needs to hold so that it doesn't go insolvent? So that is where I come in, or professionals like me come into a financial credit analytics industry. So I have not actually time to go into these details and what is this, but basically in financial industry, what you have to prove to Reserve Bank of India is that I have hold enough capital. Okay, you are happy with it, so let me run my business. So if Reserve Bank of India is not happy with the capital that I am holding, Reserve Bank of India, what will they do? They will withdraw my license to run. So as a bank, if I am a bank, they will withdraw my license to run. So I want to have profit also. So I would not want that. So I would hold that enough capital. Now, what would be that enough capital? That minimum capital requirement calculation is where the analytics professionals come in. So that's the basic example of how the credit risk analytics works. Uh, so I think yes, I am end of my storytelling sessions. I planned for a couple of technical discussions, but yes, I have discussed a few. Uh, so I think it's time for questions. So.
Uh, okay, thank you, Mr. Rajit, for this wonderful presentation. And one question from Dr. Tanoy Pramanik.
Yes.
Mr. Pal, can we use this technique in predicting the probable cases of corona patients in India in near future?
That's a very good question. That's a very good question. But you okay, to answer this question, yes, you definitely should be able to able to predict the future cases of corona. But the problem is that, so how do we predict? So we predict based on certain historical experiences, right? So we predict based on the data, and the data has to have that historical experiences. Now, this kind of pandemic, this coronavirus pandemic is very rare. Uh, and that is why whatever model actually came in after January, February, and March 2020. So there are a lot of articles also got published where they tried to capture the predicted number, or they tried to capture the future number of coronavirus cases in India, or say, let's say, globally. But where they are not very accurate, to be honest. But you have to understand that is not the fault of the techniques itself. Why are not they accurate? Very. So they are not very accurate in the sense they are not perfectly capturing the historical experiences. So we have not seen these kind of pandemic in recent past. So that is one of the reason. And the second reason is too much volatility or volatile information is actually involved in the coronavirus counts. So for example, whatever count you are seeing on the government website today, that count is actually based on the reported number of cases. That is not the actual coronavirus cases. That is the reported number of coronavirus cases. And the doctors are also agreeing on the fact that there are huge difference in the reported number of cases and the actual number of cases. So if you look at all the articles that got published in the meanwhile, while we are having this lockdown, you would see all those articles are actually having a huge number of predictions, because they are actually trying to predict the actual number of cases. But as a layman or as a general public, if you want to look at the prediction and if you want to look at the government website data, you would say that, okay, this analysis is not good, because they are predicting I'll be having 2 lakh cases per month, but my government website is showing only 60,000 cases per month. But you have to keep the fact in mind that the government's website will be showing cases based on the reported cases only. So if you are asymptomatic and if you are having some breathing problem, but you do not go to the hospital, still you might have that coronavirus, but you are not reporting that case, right? So my predictive model is not capturing that fact, and that is why the predictive modeling is actually predicting higher number of cases compared to what government website is showing. That is the difference of that huge gap. So a general public might infer that the analysis is not good. Analysis is not the best. I also agree, but it is having that gap because of not because of the default or not because of the fault in the technique itself, but rather how the data is captured. The data is captured because we are having a less number of tests per capita, that is for sure, and we are having only reported number of cases. I think, but to answer your question in one sentence, yes, of course, we can use these techniques to predict the number of coronavirus cases, but those techniques are already developed, and we have got a lot of papers published also regarding that. I hope.
Okay.
It clarifies some.
Thank you, Mr. Rijit. Yes, thank you, Mr.
Yes.
Rijit. So,
Yeah.
last question from my end actually, as most of the viewers are engineering students, so can you
Right.
share any scope for them in this current topic? So, is there any scope that they can go for after completion of their graduation? So, if you can guide them.
Yes. So right. So you do actually the beauty of this analytics field is that you do not need to be mathematician. You do not need to be a statistician or like, so anyone can actually join this field. But the fundamental need for this field is to have a solid mathematical background. So for example, to be more specific, I would be saying, so if you ask me, do you have a solid background in probability theory, or do you have a solid background in linear algebra, for example, or do you have a solid background in statistical inference? So build up or learn those skills. Those skills are very transferable. So if you are a mechanical engineer, also you can learn those skills. If you are a software engineer, then of course you can learn those skills. If you are an engineer, so that essentially means you are moderately good in mathematics, right? You are very good in mathematics. That is why you choose the engineering stream. so that mathematical skill will help you to come to this domain. Of course, after graduation, there are many courses nowadays, masters in data science or masters in analytics. I think your university is also offering some of the courses like that. I'm not sure, but uh, if not, they will be offering soon, I guess, because it is a trend nowadays, and it's a very very buzzing industry. So of course you can come, and do not worry about whatever stream I am right now. It doesn't matter whether you are in mechanical, electronics and software. Wherever you are, you can still come to this industry. And the point is that I work with many engineers who come from a different background. It's a diverse field. People from every background come into this profession, and that's the beauty of it. You get a diverse field. You get diverse experiences mixed together.
Okay,
Thanks.
thank you.
Yeah,
Thank
I
you
hope
so
that
much,
answered the question.
Mr. Rijit. So now over to okay. Now over to Sumit, sir.
Okay. Thank you, Mr. Pal, for your outstanding explanation. Is there anything to ask, Professor Shubhajit Pal? Is there anything to ask from your part? Other things?
No more questions, sir. No more questions. Thank you.
Okay. Okay. Thank you. Thank
Thank
you all.
you.
Thank
Thank
you
you, everyone.
uh, to our viewers for their patience and their participation. And a big thanks to you, Mr. Orijit Pal, for the outstanding explanation that you
Thank you.
have done all through your session. So, wish you all a very happy puja and stay safe and
Yes,
stay
yes.
home. Okay.
Same to you. Yes.
Thank you.
Thanks.